Hey guys, I hope that I'm live right now. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please let me know. Hello everyone. I hope that I'm live right now, guys. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please let me know. Are you guys able to listen to me properly? No issues with the audio or the video, please let me know. Okay, no issues whatsoever. Okay, guys. Yesterday I was not able to take up the meeting, guys. I'm still having a little bit of fever. Yesterday it was huge, so I had to rest a bit. And today as well, I'm not feeling that great. You should be able to understand that by my voice itself. But nevertheless, we will be continuing with our project from today onwards. Okay, so let me just share my screen with you guys. Give me a second. Excuse me. Give me a second, guys. Entire screen share present. Okay, so now you should be able to see my screen as well. Okay, nevertheless, let us start with our project, guys. No, guys, not at all. I'm not at all well, but yeah, I cannot delay the classes anymore. So, yes, let me open up Collab first. Okay, we were using Collab till yesterday, right? So let me just open up Collab from right up there. Okay, we need to open a notebook, recent, project one. Okay, let's connect. Okay, so this is what we had coded yesterday, guys. I hope so that you guys remember all this from yesterday. Okay, so let us try to see something about the MNIST data set. Let me open up Google Images, guys. NIST MNIST data set images. Let us see. Okay, yeah, this image will explain it to you guys very clearly what I'm talking about. So, okay, any image that you are able to see in your entire life, I have already explained this yesterday as well, right? Is basically made up of pixels. Okay, do you guys remember that? Any image that you guys have seen throughout your entire life is basically made up of pixels. Do you guys remember it? Please let me know. No, no, Sneha, that is incorrect. There is nothing like that. For the next boot camp, we might ask you to just share the information about the boot camp with your friends, but we will not allow something like that. Sneha Shish, if it's possible, could you send me the details of what has happened with you on either Instagram or LinkedIn to me personally? I will help you out with that because this is not something that we do. Okay. So if you guys remember the instance that every image is basically nothing else but a particular like red, green, and blue values, right? So in the exact same sense, here for the MNIST dataset, we are having a particular a black and white image, guys. Okay, black and white image. Are you guys able to see this? Every image in our dataset is a black and white image. Now, in the case of a black and white image, there is no use of red, green, and blue values, guys. Because it's a black and white image, it is not a colored image. So either it is black or it is white. But it is not always the case. Okay, let me open this image in a new page itself. If I zoom in on this particular image, is this particular block right over here, this block, black or white? The one where my cursor is, guys, the one where my cursor is it black, white, or is it some other color, guys? Can somebody let me know? Is it black? Is this square black, white, or some other color? The answer is gray, right? It is gray in color. It is not black. It is not purely white as well. It is gray in color. Now, how is that possible? If the image is a black and white image, where is gray coming in from? So every image can be classified into a very big as uh, your matrix. Okay, you are having a matrix right over there, right? You have studied it in mathematics. So every image can be represented as a matrix of numbers, wherein every number indicates the strength of black at that particular pixel. For example, all the space around the tree is completely white, right? All this place around the tree is completely white. So here as well, inside our matrix, all those places are completely zero. There is no presence of black right over there. The highest that black can get is 255. 255 means it is black, pure black right over there. Zero means pure white right over there. And any number in between is like a darker shade of black or gray or a lighter shade of gray and so on and so forth. So the pixel that you are able to see right over there, the gray color pixel is approximately having a value of 59. That is its value, approximately 59, guys. So as you're able to see, the entire tree can be represented by these numbers. And this entire matrix is going to be our input value for our model. The model that we are going to create in deep learning, this entire matrix of numbers. So computers cannot understand images. You need to understand this. Computers have no knowledge, no understanding of interpreting, analyzing, or understanding images. But what do they have is to able to interpret, analyze, and understand these numbers. So every single image that is stored in your computer, that is used in your computer, is actually stored and used in format of this particular matrix that you guys are then able to use and understand and see. In the exact same way as well, for our project, for our model that we are going to create, the input is going to be all these numbers, all these matrix itself. Now, okay, so if you are a AI, okay, let's think about it in such a way itself, guys. If you are an AI and you are told to take up certain decision on the basis of you don't have any basis, you have just been told that okay, these are two people in front of you. One is Mukesh Ambani, the richest person in India, and one is Shaurya has 200 rupees in his bank account. Okay, let's take that as an example. Okay, Shaurya with 200 rupees in his bank account, and Mukesh Ambani, the richest person in India. Now you have to take up a decision right over there. You have not been given any kind of help, any kind of particular um okay, you have to take the decision on the basis of money itself. You haven't been told that. You haven't been told that. But there's a very high chance that that money might, like, you might take a biased decision due to that particular money. Are you guys able to understand it? Like, you had to kill one person, let's say that. So you will be like, "Arey, that's the richest person. Let's just kill Shaurya." Like, what will happen? Okay, he has just 200 rupees in his bank account. He's not contributing anything to the society, but that fellow is contributing a lot. So you might take up a decision, a biased decision, due to the factor of money, right? Are you guys able to understand this particular example, guys? Please let me know. Are you guys able to understand this example, guys? Please let me know. Yes, no, what is the scenario? Yes. So in the exact same manner itself, guys, in the exact same manner, for a AI model as well. An AI model is looking at these image, these numbers that you're sending in to the AI. Okay. Now the lowest number is zero. The highest number is 255. And most of the numbers are either very near to zero or very near to 255 itself. Are you guys able to see this? Please let me know. Guys, while you guys are analyzing the numbers on the screen itself, if you guys are able to see it, let me just bring some water because my throat is all dry and shit. Okay. In the meanwhile, guys, just think about it. Like most of the numbers in these images are either zero or very near to 255. So there might be a bias that might be created in the AI's mind as well. You want to make sure that the difference between the inputs that you're giving should not be very great. It should not be ki, acha, one input is zero and the other input is like 255 or something like that. Try to make sure that our right now our aim is to make sure how can we make sure that this inputs we are able to bring them as close as possible. So while you guys are thinking about how can we bring these numbers as close as possible, let me just grab some water. Till then, you guys think about it. How can we make sure that instead of these numbers being from 0 to 255, how can we bring them closer together? Think about it, guys. Think about it. Any idea, guys? Any idea? Any idea that came to your mind? How can we bring these numbers closer together so that this bias might not come that okay 255 has greater value than 0? That is not the case, right? Both 255 and 0 have the same value. How can we make sure that these numbers come closer together, guys? So why these numbers are important for us? Because this is the mathematical representation of our data. Okay. Use normalization with range 0 to 1. That's absolutely correct. Just to make sure that I'm able to put it up in a noob's term itself. Okay. So if I want to bring these numbers as close as possible, I know that the maximum number is 255 itself. Why not divide every single number in this matrix by 255? What if I divide every single number in this matrix by 255 itself? What will I get? I'll get all my numbers in the matrix in between 0 and 1. Now 0 and 1 are very close to each other. So the chances of a bias coming into place that 1 is greater than 0 or 1 has more value than 0 will be very less. Are you guys able to get this? Please let me know. Are you guys able to get this? Please let me know, guys. This is called, the technical term for this is normalization. But this is what I've explained in a, like a noob's manner itself, in a like a layman terms itself. But technical term is normalization. Now to do normalization is pretty simple, guys. I think so. Everybody will be able to complete it in just one go. I'm that confident with you guys. Okay. So what data do we have to normalize? That is going to be my next question. What data do we have to normalize, guys? Which data do we need to divide by 255? Can somebody let me know? A very simple question, guys. Nothing too difficult about it. Which data do I have to divide by 255, guys? Can somebody let me know? Let me know, guys. Let me know which data do I have to divide by 255. Think about it. Which data do I have to normalize, guys? Think about it. It's pretty simple, guys. Pretty simple. If you guys are paying attention, see, if you guys are not even able to answer this, there's going to be a lot of difficulties that you're going to face further. This is like teaching somebody how to produce a sound from their mouth. A little bit more than that, like not a e u, but like yeah, maybe like a letter, right? Like tell oh, the baby says oh. Okay, so if you are not able to cope up with this at such a level, that means either three of things. First, this is not meant for you. Not everything is meant for everybody. Yes, if you pay hard work, if you do our like pay enough attention, you work your ass off, yes, it is meant for you. But currently, with your level of dedication and efforts, maybe this is not meant for you. Secondly, you are not paying enough time, you're not paying enough efforts, you're not paying enough attention. That is going to be the second thing. And the third thing is revision. You guys attend the class, you guys are paying attention somewhere else. After the class, you just forget everything. Three of the things that might happen. In all the three things, like there's nothing that I can do. It is at the end of the day, you have to decide whether you want to do it or not. Okay, so extreme and x test as well, guys. Extreme and x test. Why? Because both of these are images. You need to normalize the images itself. So extreme and x test are the only two parts of our data that contains images. So we have to normalize these two itself. Okay. So right over here, guys, we'll just redefine extreme and x test. Extreme is equals to, I hate this microphone coming in between while I'm typing. I'm not able to see shit what I'm typing right over there. TF dot KERAS scares dot utils dot, have I written the spelling of utils right? I hope so, because then it is not good, right? Normalize. Okay, and what do we need to normalize? We need to normalize the extreme, and this will take care of everything by its own, guys. So you don't have to, that is the benefit of using keras. You don't have to tell it that okay, divide everything by 255. You just have to let it know that you want to normalize it, and it will do that for you. So you don't have to go into the intricacies of taking up every image and then making sure that every pixel is divided by 255. That is all taken care by just one line of code. tf.keras.utils.normalize extreme comma axis is equals to 1. As simple as that, guys. Okay, similar to that, we'll do it for the x test as well, guys. Can somebody let me know what should be the code for that? For x test, what should be the code, guys? Can somebody let me know? For x test, what should be the code, guys? Can somebody let me know? For x test, what will be the code, guys? You guys should be able to remember it, like you have just seen it right now. It has not been one day or some shit, like you have just seen it like 2 seconds ago. Can somebody let me know what should be the code for x test, guys? Krf tf dot krs dot utils dot normalize. Great, guys, awesome. Always remember this, guys. The more that you practice, the better you will get at programming. It is as simple as that. It is not like how much intelligent you are, or from which college have you passed, or did you crack JEE mains or not. It is not dependent upon that. It's only dependent upon practice. The more that you practice, the more that you will remember. The more that you remember, the more you will be able to implement. The more that you implement, the more chances are that you guys are going to get a good placement. So please do remember this, that it is not important on which college you are from or what. It is more important what, how much are you practicing in programming. That is all that matters. Okay, so now that we have normalized our data as well, we have done everything. Now we can go ahead building our neural network, guys. The kind of neural network that we had just seen in our yesterday's class, right? I created a particular architecture for you guys. Do you guys remember? Fuck. Do you guys remember that, guys? Please do let me know. Why access? Because that is the grammar, that is the syntax for declaring the normalized function. Okay, so can you guys let me know? Yesterday we have seen uh, your particular neural network that I created, right? You are having what is utils? So utils is basically an English word. It is not a programming word itself. Utilities. Okay. So every kind of utility that you require, that will be present inside of Keras. Okay, that you can access from keras.utils. Okay. Okay, so if you guys remember the network that we created, okay, you are having 10 neurons in one layer, then you had 5 neurons in the next layer, then 10 neurons in the next layer, and then one output neuron itself. In the exact same manner, we are going to create our model right now inside of Keras, inside of TensorFlow. We call such type of models as sequential models. Why sequential? Because the layers are in a sequence: first layer, second layer, third layer, fourth layer, and so on and so forth. So we call them as a sequential model, guys. That is a technical term for it. So just remember that, otherwise you guys will be blaming me that I didn't tell you. So let's define our model first, guys. MODEL model is equals to TF dot keras dot models, and we need to select the sequential model. Please remember, Python is a case sensitive programming language. So if I'm writing a capital S, you also have to write a capital S. If I'm writing a small t, you have to write a small t as well. So do not fuck it up. Okay, otherwise you will be saying, sir, code kaam nahi kar raha. So I cannot do anything about it. Okay. So this will create a sequential model for us, guys. Now we can start defining the layers that are going to be there inside of this sequential model. Okay, we need to define each and every layer individually itself. I'm so sorry. Okay, so every layer that we are going to create right now, okay, we are going to create it inside of the sequential model itself. So the model has been defined as sequential, but every layer you will have to add it to the model itself. Now, the first particular layer that we need to add is the input layer, guys. The input layer that is going to take in the input inside of the model itself. So what is the input in this case, guys? Can somebody let me know? What is the input in this case, guys? Can somebody let me know? X test and X train. Okay, X train is the input right over here. But what is contained inside of X train, guys? What is present inside of X train? Can somebody let me know that? What is present inside of X train, guys? Can somebody let me know that? Images. Which images? What is the property of that image? What image is the input? And what is the property of that image? What is the size of that image, guys? How many pixels? What is the width and height of that pixel? Sorry, of that image, guys. Tell me, think about it, tell me. So basically, our input is an image. There's a matrix of 28 by 28 pixels. Am I right or wrong, guys? What is semantic segmentation used for? SSSS? Wait till the end of the class. Right now, I'm not going to answer this question because it is irrelevant to what we are learning. Wait till the end of the class. While I have given the attendance, ask at that point of time. So I'll explain it to you, but be very prompt with it. Otherwise, I'll forget. Okay. So now a 28 by 28. So let's draw it out so that we are able to see this a little bit more clearly. Then maybe you guys will be able to understand this. Give me a second, guys. Where is my pen? Give me a second, guys. I need to find my pen. My pen. Yeah. Got it. Okay. So let's try to understand this, guys. This is our input. Okay. This is a 28 by 28 pixel matrix itself. Now, the input for our algorithm, for our deep learning model, looks basically like this. How can we feed a matrix as an input inside of these neurons? That is the question right now. This is linear, right? This is in one dimension itself. This is two dimensions. How can we feed a two dimension into a one dimension area, place itself? How can we do that? How can we do that, guys? Think about it. Our image is a 28 by 28 pixel image itself. We need to put it up inside of one dimension. How can we do that? Can we convert to 2D? No, you can't. You have already defined, right, that this is your input layer. You've already defined that. So if that is defined, how can we change this particular 2D into 1D so that we are able to feed it right over here? Now, if you think about it, these rows that are there, okay, they are stacked on top of one another, right? Such as this. If this is your first row, then this is your second row itself. They're stacked on top of one another. What if we bring them side by side? Instead of them being on top of each other, what if we bring them side by side? So, for example, this particular row will then come here. This will go off. There's nothing right over here itself. In the exact same manner, this will then go here. So again, this will come here itself. Then again, this will go off. This does not exist. Then again, this will come here. Again, this will vanish. Then again, this last one will go at the end. So in the same way, can we convert this image of 28 by 28 pixels or 28 by 28 matrix itself into a one dimensional array, into a one dimensional like event itself? Can we do that? Can we do that, guys? Please let me know. Are you guys able to understand what I'm talking about? Like how to do it? That is for me to teach to you guys. But are you able to understand this logic? Like by doing this, I can convert into a one particular array that has 28 multiplied by 28 elements inside of it. That is the total number of elements, because all, and if you're not able to understand this, then you require a notebook and a pen, okay, for the rest of the classes. Whenever you're not able to understand something, draw it out and understand it. That is the only case in which you will be able to understand stuff. No matter how I tell you guys, you will not be able to understand it. If you're still not able to understand, take a notebook and a pen when you're sitting in the class. I promise you this, that you will be able to understand each and every stuff that I'm telling you. Okay, because I visually explain everything to you guys. The technical term for doing this is called as flattening. Okay, it's called as flattening. Okay, so for example, girls get a boob job, right, to make sure that everything is big. Okay, so we are doing the opposite. We are men. Okay, we are opposite. We like to do flattening itself. Okay, this is just a very, very, very bad joke from my end, but I'm not very good at making jokes as well. So we will do this. Okay, we will flatten this up right now. Now flattening is going to be very simple, very easy, guys. It is going to be done in just one line of code. That's it. That is literally the benefit of using Keras. Everything is simple. I don't have to read between the lines itself. Like when you are having a girlfriend, right, you have to read between the lines. Every two lines there is a third meaning, which has a fourth meaning, which has a separate understanding about the topic. But with Keras, you just have to write the stuff properly, and voila, everything will be working for you. You just need to understand stuff properly. Okay, the more that you practice, the more you will be able to understand. But believe me when I say this, the more that you try to understand a girl, the farther you will be from that. Okay, always. For those who are in a relationship, they will be able to understand this. For those who are not, हर कुत्ते का दिन आता है, तुम्हारा भी आएगा, टेंशन मत लो. Okay, so let's continue from right over there itself. So the next thing that we're going to do is we're going to add a new layer to our sequential model that we have created. Now, this new layer that we are going to add is going to be the input layer, guys. It is going to be the input layer. Okay. Now, this input layer is actually the image plus flattened. Okay. But flattened to one dimension itself. Okay. So, model, that is the name of our model, guys. We have written it in the above code itself. Dot add. Okay. We want to add a new particular uh, neuron layer right over there, guys. So model dot add, and then we have to add our tf dot keras. You always remember this, guys. Tf dot keras. You have to use it every single time. layers layers dot fla. Okay, very bad. fla tten flatten f capital, guys. Do not forget about it. Now, what is the, so we have told that okay, it is a flattened layer itself, but what is the input shape of the images being fed to this flattened layer? So basically what is happening is this layer is going to take in the images, flatten them up into one dimension itself, and then use it for the later layers itself. That is what it is doing. So what is the input to this flattening of the layer itself? That is the shape of our image. It is 28 by 28. So guys, able to understand this? This layer will take in the image as an input, will flatten it up, and then use it for the later layers. So we need to give it the input size of the image as well. That is input shape. Input shape, okay, and that input shape is going to be 28 comma 28. That is the input shape for our layer itself. Let us run this. Let us build like add our very first layer. So this is the input layer, guys. This is the most simplest format of layers. Okay, now do you guys remember the relu activation function, guys? Do you guys remember the relu activation function, guys? Please let me know. Can we use another method than flatten? Absolutely yes, but you have not still learned it, so I'm not going to talk about it. Otherwise, people will get like confused. I don't want people confused. I want people to understand stuff. Okay, but yes, there are multiple other ways of doing things. Multiple, like I can think about in my head at least 12 more ways of doing it right now. I can think about those, but yeah, for talking about it would be like people get confused, so just try to understand this one. Okay, so the next thing that is there is to add more layers inside of our uh, model itself. Now, adding more layers is going to be very simple, right? Model dot add tf dot keras dot layers. Okay. Now, this type of layers that we are going to add right now, if you guys remember, right, the second layer of our model from yesterday's class, the second layer of our model took in inputs, like the inputs were all the particular inputs from the first particular layer. It was an input to one single neuron, and that one single neuron was connected to all the neurons in the next layer as well. Do you guys remember that? Like one neuron is connected to all the neurons in the previous layer as well as the next layer. In a simple manner, every single neuron present in this layer is connected to every single neuron present in the first layer, is connected to every single neuron present in the next layer as well. These type of layers are called as dense layer. The technical term for these type of layers is dense layer, guys. So we are going to add two dense layers right over here. Okay, two simple dense layers right over here with 128 neurons in each. Again, 2 to the power. Please do remember that. So let's do that. Model dot add tf dot keras dot layers dot dense den. Why is this not coming up? Dense, and then our parenthesis right over here. Then first we need to submit how many units or how many neurons are going to be there inside of this dense layer. So UNITSU submitted by units. Units is to 128. And what is the next most important part about this layer, guys? Can somebody let me know? What are the two things that I should? This is something that we have discussed yesterday. So I'm not going to like give you the answer. But I want you guys to make me understand what is the second most important thing that is needed by this layer. Second most important information needed for this layer. Dense basically means that neurons present in this particular layer are connected with every single neuron present in the next layer and every single neuron present before that as well. So all the neurons are interconnected. That is called as a dense layer itself. Okay. So can you guys let me know? So number of neurons we have already put in right over there, right? 128 neurons. That is the first most important thing. What is second most important thing needed by that particular layer? So why do we use 128 neurons? You can use as many neurons as possible. Again, you can use 130 neurons as well. You can use 1500 neurons as well. It is up to you guys. For me, I use this because I've already done this project and this gives the best results. So I'm just using that. But again, that is through trial and error. Okay. And sometimes through like understanding as well. Weights, no, that is not the right answer. Guys, come on, guys, think about it. What is the second most important thing for this particular layer? Come on, guys. No, not black box. That's also wrong. Come on, guys. Think. Activation function. Great. Poly activation function. Activation function is something that is important for that layer, right? Without that, how is it going to work? So you need to define which activation function is this particular layer going to use. And that is going to be the ReLU activation function that we have already discussed in our previous class. Okay. So just write activation. That should get us there. Activation is equals to and tf dot and n dot relu. Okay, this will get us the relu activation function, guys. Let us run this. Okay, we need to add one more layer, guys. We need to add one more layer. So let us add that layer. It is going to be a copy paste of this layer itself. So I'm not going to use a lot of efforts from my end. Just Control C and Control V. Okay, so two layers I've created with the same activation function with the same number of units as well. So let us run this. So two more layers have been added. So right now, how many layers does our model have? Can somebody let me know? Can somebody let me know how many layers does our model have right now? Think about it first. How many layers does our model right now has? The answer is 3. The flattening layer is also a layer, guys. The flattening layer is also a layer. Okay, so 3 layers are currently there right over here. Now we need the last layer, the output layer, guys. Now the output layer basically tells us what are we going to predict? That is the first question. Guys, what are we going to predict? What do you think this model is going to predict? Please do let me know. What is this model going to predict for us, guys? Please do let me know. Think about it, guys. Numbers, no, wrong. Wrong. Numbers. If somebody's saying numbers, wrong. Or explain numbers. Okay, what do you mean by this numbers? What are we going to do, guys? Think about it. Think about it. Come on. We are going to predict the probability that a number is 0, that a particular image is of 1, a particular image is of 2, and so on and so forth up till 9, from 0 to 9. And then the one that has the highest probability, let's assume the image has the highest probability in 7, that is the one that we are going to use as our answer. This particular image mostly maybe has 7 present inside of it. Are you guys able to understand this? Please let me know. We are going to predict the probability of that image being a certain number. So now think about it. How many neurons are needed in the output layer, guys? While I'm writing the code, I want the answer from you guys. How many neurons are needed in the output layer, guys? Think about it. Let me know. Till then, I will just write the code dot add tf dot krs dot les dot dn sentence. Guys, what is the answer? How many units should I put in up right over here? How many units should I put it on right over here, guys? The answer is 10. Because for every neuron that is present in the output layer, we are trying to get the probability from that particular neuron of that particular number itself. So units, we are going to keep it as 10. And activation, whenever you want some to deal with something like probability, you use softmax as your particular go to activation function. tf.nn.soft softmax, I think so. That should get it. Okay, it did not. Soft max. Okay, if you want to see the soft max as well, no issues in that. So ftmax activation function. So this is the softmax activation function, guys, in which the answer will always be between 0 and 1. That is like a probability itself. So whenever you want to get your final answer as a probability, you use the softmax function, because that gets you like the answer between always between 0 and 1. The softmax function equation is this. You guys need to remember this. Okay, there is like no other option. Some of the famous equations, you guys will have to remember it with their graphs and everything. So I'm being very frank about it, and I'm letting you guys know right now itself, so that at a later point of time you guys don't tell me that sir aapne nahi bataya ki this is also important for us. Okay, so we'll add that last layer as well. Now we can see a basic understanding about the model by just writing model dot summary. And this will give us a basic understanding of the model that we have created, guys. So as you're able to see, this model is a sequential model. The first particular layer is the flattening layer itself, that has a shape of 784, that is 28 multiplied by 28. The second layer is a dense layer that has 128 neurons inside of it. Dense 1 that has again 128 neurons inside of it. Dense 2, that is the output layer, that has 10 neurons inside of it. Total number of weights or total number of parameters are more than 1.18 lakh. That is the total number of weights that are there. A, B, C, D, if you guys remember. A of x1 plus B of x2 plus C. Okay, so those A, B, C, D, the weights that are also called as the parameters, are 1.18 lakh. So if you try to create a variable, an equation that is able to solve this, it will need 1.18 lakh variables itself. So yeah, that is the reason why I usually say take it up as a black box. Do not think about it a lot. Basic mathematics should be understandable by you guys, but not in a lot of depth. Okay, so are you guys able to understand everything up till here, guys? Please let me know. Yes. Okay, so today we have completed building our model, guys. Tomorrow we will look into the rest of the stuff, and then we'll continue from there, because I'm not able to speak any longer. My voice is going away slowly and steadily. Why output 10? Dude, like I explained the entire fucking thing. What were you doing then? Like I explained, right? That okay, there is a particular like output. What are you going to predict? The probability of that image being a certain number. So for every number, you will have to show that probability. Then you just take up the highest probability, and that is the answer for you. So how many output neurons do we need? 10 neurons, because every neuron will show the probability for every number that it represents. So yeah, okay. Now let us take up the attendance. And once again, guys, please be on time. Okay, how are you to do these free boot camps? Dude, I have my own job. I work from 9 to 5 itself in an IT company. I've been working for almost 5 years right now. So yeah, this YouTube thing is something that I like doing. Like, I did it in college. I liked it. So since then I have been doing this. And yeah, people sometimes appreciate it, people sometimes don't, but I usually don't care about it. Okay. So the attendance is in the live chat, guys. You guys can start filling up your attendance. We'll meet in our tomorrow's class and we'll continue from right over there. Thank you so much, guys. The attendance link will be closed as exactly 9:07, guys. Thank you. Thank you so much.